Morse code began as a simple way to send messages over long distances using electrical signals and wires, long before satellites or fiber optic cables were imagined. In the early 19th century, inventors and experimenters were trying to turn electricity into a practical communication tool that could travel faster than a horse or a ship. Samuel Morse, an American painter and inventor, worked with collaborators like Alfred Vail to create an electromagnetic telegraph that could send pulses along a wire. To turn these pulses into language, they needed a system of symbols that could be transmitted as short and long signals. The earliest form of Morse code used patterns of dots and dashes to represent letters and numbers, chosen with the idea that the most common letters in English would have the simplest patterns. This early arrangement was designed for a specific machine and a specific language, and it would later be modified as people discovered limitations and inconsistencies. Operators listened to the rhythmic clicking of sounders or watched needles and marks on a paper strip, slowly learning to understand the patterns as if they were a spoken language. Over time, as telegraph networks spread, this code became an essential part of business communication, news reporting, and government traffic. With each new line of wire, the need to coordinate and standardize the code became more visible. Local habits, national preferences, and small technical changes gradually made the original design less uniform from one region to another. The first versions of Morse code were tailored to English and to the early telegraph instruments that printed marks on paper tape. Each letter was assigned a sequence of dots and dashes that would be recorded as short and long marks along a moving strip of paper. Operators then read these marks as characters, almost like reading a slow, mechanical handwriting. As technology improved, telegraph operators began listening directly to the clicking sound of the electromagnets instead of reading the paper tape. The printed marks became less important, and the sound patterns took on a new role. Because of this shift, some of the original choices in the code felt less convenient, especially when used at higher speeds. Outside the United States, other countries were building their own telegraph networks and were not always using exactly the same patterns. Some regions had adopted different sequences for punctuation marks, special symbols, and letters that needed accents or additional sounds not found in English. This meant that a message sent from one side of a border could arrive on the other side with possible confusion or the need for translation of the code itself. As international communication increased, this patchwork arrangement began to show its weaknesses. Commercial firms, railway lines, and news agencies all benefited from a single consistent set of rules. Step by step, the idea of a truly international Morse code started to take shape in technical meetings and official proposals. The need to create a unified code became clear in the middle of the 19th century as telegraph cables began linking countries together. Landlines crossed borders, and submarine cables were laid under seas and oceans, connecting distant continents with thin strands of copper. Governments and telegraph companies realized that each region using its own variant of Morse code caused delays and occasional errors. In Europe, a separate version known as Continental Morse code had developed, optimized for the languages and practices of operators there. This code differed from the American version in several letter patterns and punctuation marks, even though both systems shared the same general idea of dots and dashes. Conferences were organized where engineers, telegraph officials, and scientific representatives met to discuss standards for international telegraphy. The goal was to choose one code that could work reasonably well for multiple languages and that could be taught to operators in many countries. These discussions considered not only the patterns for each letter, but also the timing of signals, the spacing between elements, and the way errors should be handled in everyday operation. Out of these efforts emerged a system that would eventually be recognized as International Morse Code. While it did not erase every regional practice at once, it provided a formal reference that could be adopted in official telegraph traffic across national boundaries. International Morse code simplified and adjusted the earlier designs to work more smoothly in practical use. Some letters that had been awkward or slow in American Morse were given new patterns, and the overall set of characters was realigned. The code kept the principle that very common letters such as E and T would have the shortest signals, a single dot or a single dash. Less common letters received longer sequences, with a balance between distinctiveness and speed. Numbers, punctuation, and a few procedural signs were also defined, allowing not just words but structured messages to be sent. The structure of the code made it possible to tell where one symbol ended and the next began by respecting standard timing intervals between dots, dashes, letters, and words. Telecommunication organizations gradually adopted these timing rules so that equipment and operators from different places could cooperate without confusion. While American Morse stayed in use within certain domestic networks for some time, the international version gradually dominated wherever messages crossed borders. The result was a shared technical language that did not depend on speech or writing systems, but on sound and rhythm. From busy coastal stations to quiet rural telegraph offices, operators learned to send and receive this standardized pattern set, often for long hours every day. Over the decades, the code became closely associated with the discipline and routine of professional communications work. Standardization did not happen overnight, and formal agreements were needed to maintain consistency as new symbols were added. International telegraph conferences, which later evolved into permanent organizations, created rules and recommendations for all aspects of telegraphy. Committees documented the official forms of the International Morse characters, preserving them in technical manuals and regulatory texts. When telegraph practices overlapped with early radio transmission, the same code found new life in wireless communication. At sea, ships equipped with radio sets needed a reliable way to send distress calls, routine traffic, and navigation information. The standardized code allowed a vessel from one country to communicate with coastal stations and ships from many others without needing a shared spoken language. This stability helped reinforce the choice of International Morse as the reference system for global use. Over time, special signals such as the famous distress sequence were defined in official regulations, specifying not only the pattern of dots and dashes, but also the way they should be transmitted in emergencies. As new technologies like radio telephone and later digital systems appeared, the code remained embedded in the frameworks that governed long-distance communication. The clear, documented nature of International Morse made it straightforward to include in training programs, manuals, and equipment design specifications. To maintain a code that worked worldwide, exact timing rules became as important as the dots and dashes themselves. The length of a dot served as the basic unit of time. A dash was defined as 3 units long, while the space between elements of the same letter was 1 unit. The space between letters in a word was standardized at 3 units, and the space between words at 7 units. These proportions created a rhythm that made symbols distinguishable even over noisy connections or with imperfect equipment. Telegraph schools and radio training programs carefully taught these timing conventions to new operators who practiced until the patterns became automatic. While some skilled operators could recognize words and phrases as continuous sound, the underlying timing rules remained the same. When automatic telegraph transmitters and decoding devices arrived, they were designed around this standard timing framework. The equipment would imprint or interpret sequences according to the same unit lengths that human operators had been using. Standard timing also made it easier to design filters, relays, and recording systems that could handle traffic from many different stations without local adjustments. The consistency in both pattern shapes and timing is what allowed International Morse Code to remain compatible with a wide range of technologies over many decades. Morse code did not only consist of letters and numbers, but also a set of procedural signs that supported routine operations. These special sequences, sometimes called prosigns, provided instructions like starting, ending, correcting, or repeating parts of a message. For example, operators had distinct patterns to indicate that a transmission was finished and that they were waiting for a reply, or that all traffic for a particular station had been sent. In daily work, these signals reduced ambiguity and helped maintain order on busy lines. Standardization meant that operators in different services and countries used the same procedural patterns, at least in international traffic. Manuals and operating codes described when and how to use each sign, shaping a common professional practice. Even when languages differed, the prosigns created a predictable structure to the exchange of information. Over time, additional signs were introduced for new applications, such as broadcasting messages that were not addressed to a single station or distinguishing priority traffic. The regularity of International Morse made it easy to incorporate these functions without reshaping the entire system. Each new procedural pattern was simply another arrangement of dots and dashes that fit within the existing framework. In this way, the code quietly adapted to changing operational needs while keeping its core structure intact. With the spread of radio communication, International Morse Code became a familiar sound not only in telegraph offices but across much of the world. Naval ships, merchant vessels, coastal stations, and early aviation services all relied on this standardized system at various times. Training programs ensured that radio operators could send and receive at specified speeds, measured in words per minute, using the international patterns. Standard message formats were established, including preambles, routing indicators, and service abbreviations, all framed by the common code. For distress and safety traffic, regulations emphasized clarity and discipline, requiring operators to follow precise procedures. The adoption of International Morse by maritime and aviation authorities reinforced its role beyond traditional wire telegraphy. At sea in particular, the code became part of the routine soundscape, with regular calls, weather updates, and traffic lists tapping steadily through headphones and loudspeakers. Even as new voice and data systems appeared, the code retained a place in backup and emergency roles for some time. This continuity was possible because the standardized patterns did not depend on complex machinery, only on a way to turn a signal on and off in a controlled manner. In isolated locations or under difficult conditions, that simplicity remained valuable. International organizations played a central role in keeping Morse code specifications aligned as technologies and regulations evolved. Bodies such as the International Telegraph Union and later the International Telecommunication Union published recommendations that included official versions of the code. These documents specified not only the character patterns, but also usage conventions for various services. When countries gathered to negotiate radio regulations or telegraph agreements, the standardized code formed part of the technical foundation they shared. Amendments and updates were recorded in formal proceedings, making the evolution of the code traceable over time. When certain services no longer required Morse for routine operations, the standards did not disappear immediately. Instead, they often remained in annexes or historical sections, available for specialized or legacy uses. This careful documentation helped preserve the exact form of International Morse, even as it became less visible in everyday commercial work. Museums, archives, and training institutions kept equipment and manuals that illustrated how the code had been used. In many ways, the standardization process created a lasting record, not just of the patterns, but of how societies had organized long-distance communication across different eras. The code thus moved gradually from a central working tool to a more historical and specialized presence in the larger telecommunications landscape. The rise of digital communication, satellites, and high-capacity networks gradually reduced the everyday need for Morse code in professional services. Automated teletype systems replaced manual telegraph work, and later, computer networks and data links took over many of the functions once handled by coded signals. Maritime authorities eventually phased out mandatory Morse for distress and safety in favor of new digital selective calling systems and satellite-based methods. Aviation also moved toward voice and data solutions that no longer depended on manual code skills. Despite these changes, the formal definition of International Morse persisted in standards and in the practices of certain specialized communities. Amateur radio operators, for example, continued to learn and use the code for personal communication, technical experimentation, and contests. In this environment, the international standard remained important to ensure that stations around the world could understand one another. The code shifted from being a universal commercial necessity to a more optional, though still structured, means of communication. Manuals and training materials still referred to the internationally agreed patterns and timing rules, even if they were now used mainly by enthusiasts and a smaller number of professional operators. In this quieter role, the code and its standardization history remained a background presence rather than a daily necessity for most people. Beyond professional use, International Morse Code found a place in education, hobbies, and cultural references. Training exercises in some schools and organizations used the code to teach concentration and timing. Hobbyists built simple transmitters, keys, and decoders that followed the international patterns, often learning about electronics and radio along the way. The regular arrangement of dots and dashes for each character made it straightforward to print tables and reference cards, which circulated in handbooks and posters. In literature and media, the code frequently appeared as a symbol of remote communication or patient signaling across distance and obstacles. Even in those representations, the standardized patterns gave a consistent technical backdrop, whether or not viewers recognized the exact sequences. Amateur radio organizations included the International Code in their licensing materials, reflecting its continued role as a recognized communication mode. Because the rules were stable and well documented, people could learn the same code whether they studied from a handbook published decades ago or from a modern online resource. The standard thus helped preserve continuity across generations of learners who might never use telegraphy in a traditional workplace. In this more relaxed context, the code remained a steady, unchanging reference amid rapid changes in other communication technologies. Today, International Morse Code exists as a stable and well-defined standard that reflects more than a century of refinement and cooperation. The patterns for letters, numbers, punctuation, and procedural signs are recorded in technical documents, reference books, and training guides around the world. Although high-speed digital systems now carry most long-distance messages, the code continues to serve in specialized activities and in the memories of those who used it in earlier times. The story of its standardization shows how many small decisions about timing, symbol shapes, and usage rules can accumulate into a shared global practice. Across telegraph wires, radio waves, and educational projects, the same arrangements of dots and dashes have linked countless operators and listeners. Even as technology moves forward, the international form of Morse remains a clear example of how a simple idea can be shaped into a common language for machines and people. The slow and steady nature of the code, and the patience required to learn it, stand in quiet contrast to the faster systems that followed. Yet the structure is still there, available whenever a basic on and off signal needs to carry written information. Thanks for joining us for this quiet look at the history and standardization of International Morse Code. If you are still awake, please stand by for our next program.